You are welcome back to Idowu Math class. The last concept here under whole number is highest common factors, HCF. We are going to look into it using two methods like we did in LCM. We are going to use long division method and product of prime factors method. Let's use the long division method first. To find the HCF, listen carefully. There is a very sharp difference between LCM and HCF in that we use for the HCF only the factor that can divide all the numbers involved. The factor that can divide 36, that can divide 48, that can divide 60. That's all we use. We don't do like we do in LCM. You know, in LCM, out of 2 or 3 numbers, once a factor can divide one of them, even though it may not be able to divide the other, we use the factor. We don't do that in HCF. So, what factor can divide 36, 48, and 60? You can see it's 2 here. So, 2 in 36 is 18. 2 in 48 is 2, 4. In 60, that is 30. What else goes? 2 also goes. 2 in 18, that's 9. In 24, that's 12. In 30, that's 15. What else goes in all of them? That's 3. 3 in 9 is 3. 3 in 12 is 4. 3 in 15 is 5. What else goes in all? Nothing again. Nothing goes at the same time in the 3 numbers involved. Therefore, HCF, the highest common factor of the 3 numbers 36, 48, and 60 is 2 times 2 times 3, which is 2 raised to power 2 times 3 in index form, or 12 as a number. Now, using the other method, we list the 3 involved numbers like this, and we write each of them as a product of their prime factors. You write 36 as 2 raised to power 2 times 3 raised to power 2. Do you understand? You should be familiar with the way we raise this. You can do it on your own, you see you get this. Also, 48 is 2 raised to power 4 times 3. Let me give you one insight. 2 raised to power 4 is 16. 16 times 3 is 48. Also here, 2 raised to power 2 is 4. 3 raised to power 2 is 9. 4 times 9 is 36. Do you get it? So, also, 60 is 2 raised to power 2 times 3 times 5. What's the insight here? The insight here is 2 raised to power 2 is 4. You know that 3 times 5 is 15. So 4 times 15 is 60. But as small children, you can make the table for each of them to be sure you are not wrong. Now, having expressed each of them as a product of their prime factors, how do we extract our HCF in this regard? Don't forget, for the LCM, L means lowest. So in that LCM, we pick every available factor in their highest power, opposite of lowest, highest, in their highest power. Now we do the same here. H is highest. Opposite of H, the highest is lowest. So here, we pick only the common factors in their lowest power. The opposite of highest. In their lowest power. Code it somewhere. You can jot it in your notes that when you are picking the HCF, you pick the common factors in their lowest power. Let's go. What are the factors that are common to the 3 numbers? You can see that factor 2 is common because factor 2 is here, is A. Factor 3 is also common. Factor 3 is A, is A. Factor 5 is not common. Factor 5 is present with 60, is not with 48, is not with 36. Therefore, pick those common factors in their lowest power. Factor 2 is common. Factor 2 raised to power 2 is here. Factor 2 raised to power 4 is there. Factor 2 raised to power 2 is there. Which one contains the lowest power? 2 raised to power 2. You don't take 2 raised to power 4. That one contains highest power. So, what else is common? Factor 3. But you take it in its lowest power. We have factor 3 raised to power 1 here. 3 raised to power 1. 3 raised to power 2. Which one is containing lowest power? That is 3 raised to power 1, which is times 3. Mind you, when you see 3 without any power, there is power 1 there, invisible. There is a power 1 on top of 3 here, invisible, which makes it to be ordinary 3. 3 raised to power 1 is the same thing as 3. So, this is the HCF, or you write 12. Come and look at it under the long division method. You can see that the answers are the same. There is no diversion, there is no discrepancy, there is no difference. So that is it. Let's consider example 2. Find the HCF of 18, 12, and 30. As usual, we are going to use the two methods for the question as well. Using the long division method, 18, 12, 30. We look for the factor that can divide the three numbers at the same time. Obviously, 2 can do. 2 in 18 is 9. In 12 is 6. In 30 is 15. 2 cannot divide 9. It cannot divide 15. It can only divide 6. So 2 will not be used again. 3 can divide the 9, the 6, and the 15. So we use 3. 3 in 9 is 3. In 6, 2. In 15 is 5. Nothing again can divide the three numbers at this level. Therefore, HCF of 18, 12, and 30 is 2 times 3, which is 6. 2 times 3 as a product of prime factors, or 6 as a number. Now, let's use product of prime factors method. We express 18 as a product of prime numbers or factors, 2 times 3 square. 3 square is 9. 9 times 2 is 18. Also, 12 is 2 raised to power 4 and 2 raised to power 2 times 3. 2 raised to power 2 is 4. 4 times 3 is 12. 30 is 2 times 3 times 5. 5 times 3 is 15. 15 times 2 is 30. So that is it. Don't forget to obtain HCF when we use product of prime factors method. Just take only the common factors in their lowest power. 2 is a common factor there. You can see it. 3 is a common factor there. 5 is not common. It only exists in 30. So we take 2 as the common factor with lowest power. 3 also is the one with lowest power. We have 3 raised to power 2, then we have 3 raised to power 1. So answer is this, or 2 times 3 is 6. As you can see, it's the same thing as the long division method. Let's consider this example 3. What is the HCF of 2 raised to power 5 times 3 raised to power 2 times 7, 2 raised to power 3 times 5 raised to power 2 times 7 square, and 2 raised to power 2 times 3 times 7 raised to power 3 in index form? When question is asked this way, you don't have to bother yourself on long division method again. You have been given the question in product of prime factors approach. Therefore, you are expected to use product of prime factors approach to solve it. I hope you understand me. So, and your answer is even expected to be in index form according to the question. So let's go. Just align them as 2 raised to power 5 times 3 raised to power 2 times 7. Also 2 raised to power 3 times 5 raised to power 2 times 7 raised to power 2. And lastly, 2 raised to power 2 times 3 times 7 raised to power 3. Therefore, HCF in this regard will be the product of the common factors across the 3 set of numbers taken in their lowest power. What factor is common here? 2 is common. We have 2 raised to power 2, 2 raised to power 3, 2 raised to power 5. So we take 2 in its lowest power as 2 raised to power 2 times, what other factor is common? 3 exists here, it doesn't exist here. So 3 is not a common factor in this, 5 is not, but 7 is another common factor. So we have 7 raised to power 1, 7 raised to power 2, 7 raised to power 3. Taking 7 in its lowest power, it is 7 raised to power 1, which is this. And the question says in index form. Because it is in index form, our answer is 2 raised to power 2 times 7. If it is not required to be in index form, you can leave it as 2 raised to power 2 times 7 index form or as 28. 2 raised to power 2 is 4. 4 times 7 is 28. You can leave your answer as 28 if it is not required to be in index form. But look up, the question requires it to be in index form. So we leave our answer as 2 raised to power 2 times 7. Let's have this assignment as our take-home assignment. Lay hands on the assignment and do good to get it right. When next we meet, we see to the solution of the assignment together. Till we see in the next class, bye-bye.